Hi, this is Dave Farina for my last module, Module 6 of ACTE 651. I've chosen an activity to share with you today that I've completed in my classroom, and I think you're really going to enjoy it. The activity I'm choosing to talk about today is actually number 1 in my Module 4 discussion, which I shared with you, Our Cosmic Connection. And this was made by a woman named Donna Young, who I actually met when I was at NSTA this past summer, or fall, I should say. And this article was actually part of the February 2005 NSTA magazine. And the idea behind this is that you, in your classroom, are able to come up with these activities that show our personal cosmic connection with our universe through the HR diagram and the formation, life cycle, and death of stars. And I really like this activity because I think it's neat to show students that this is not just something that's in a textbook, that you can actually go out and look into the universe and to see these things for real. Now, with the Donna Young activity that allows students to see this cycle happening, she just has these cards that basically give students the different formation steps of a star, the different parts of the life cycle of a star, and the death of a star in and there's also a website that is linked to these activities that's digital, which is kind of cool. And the students are really going to be able to get a good understanding of what's going on. I took it one step further with the help of Donna. I've actually stayed in contact with her after meeting her. And I created an activity where my students were going to do a semester project. And in their semester project, the idea was for them to basically get the same experience, but have to do the research on their own. So I'm just going to browse through this today and show you kind of what they did. So first off, there were a number of chapters that were associated with this topic that were in our book. Chapter 9, Family of Stars. Chapter 10, Interstellar Medium. Chapter 11, The Formation of Stars. Chapter 12, Stellar Evolution. Chapter 13, The Death of Stars. And finally, Chapter 14, Neutron Stars and Black Holes. So what I first did is I made groups of 1, 2, 3, 4, 5, 6 students. Some students had only 5 students or 4 students, depending on the groups. I allowed them to each have one of these chapters that they were the expert on, and I created a jigsaw activity. And in that jigsaw activity, there were, of course, people who were professional family of star topic experts, and they learned about their one topic, and then they would combine those together as a group to create this picture of the universe around us, the cosmic connection. And I framed it as a mystery. So, mysteries of the cosmos, fingerprints of stellar evolution in the Milky Way. So, I'm asking students to take actual data from our universe using a product called Starry Night, which you may have seen before. Starry Night is planetarium software. And what we did is we can manipulate the sky and we can find the Milky Way. So here's the galactic guides, here's the grid, here's the equator. And so this is the entire region of our sky on this line here that I'm following right here. That's somewhat purple. This is our galactic plane. So I can then turn on the Milky Way. So we'll make it a little bit brighter so that we can see it a little bit better. Make it much brighter. And we can even change the type of light that we're looking at. And while we're doing this, we can see how it matches up with what's in the real sky. So for instance, here we've got our infrared light, which is really important to the formation of stars. And students can get a real understanding. They can even zoom in and see how that matches up with certain types of objects. For instance, We could look at the Messier objects, which are random different types of deep space objects. For instance, here are the labels of some of those. So the Crab Nebula, M1. So Crab Nebula is a supernova remnant, the death of a star. And we can match that with the different types of light. So for instance, we want to look at Crab Nebula. Notice it's pretty weak in the infrared, but if we change our view to something like, let's say, X-ray, it should become very bright, and there it is. So we can talk about the electromagnetic spectrum in a way that is more intuitive, and it allows students to have some choice, which brings me to scientific inquiry. It really allows students to be inquisitive and actually look at these problems and see how exactly they connect with the project. So to go back to the project, they have some information here they need to gather. The first one is stellar properties. They need to find out about the stars within a certain area of the sky. And all students are asked to follow the Milky Way, and I give them an area of the sky that they get to work with based on the constellations that exist within that area. Second, they need to look through, sorry, I'm flying around here, the pre and post stellar objects. So these are the things that make stars, and then these are the things that are found after stars are dead. Multiple crime scenes. So in this particular part, we want to point out that no matter where you look along the Milky Way, you're going to see the same things happening. In other words, this is a universal property of the universe. It's inherent to the formation of stars. Group HR diagram. So they're actually asked to make an HR diagram. Group research paper and poster. In this part, students are asked to write a paper. I'll show you an example of that. They also were asked to make a poster, and in our project we had a limited time, and we did not get to this point, but in the future we will. We also have an advanced research and bonus opportunity with a collaboration between Penn State main campus, telescopes from what are called Minerva, which I'll show you in a second, and our school district. They're based on a rubric, and I'll just fly through these for the sake of time. So if you want to see more of this rubric, I would suggest you pause your video. So this is the Minerva telescope array, and Minerva is a number of different telescopes that are working throughout many different universities, Penn State being one of them, also Harvard, as well as a few others, and the Smithsonian. And you can check out their website right up here. So in their project, the students are required to gather data. This is a diagram of their sky they get to draw by hand. So we get some of that drawing that I discussed. They make a key. They create their own symbols. We also gather stellar data. This is directly from websites. For instance, the Aladdin data system is something that is used by actual scientists. We gather data from there. They've got questions that are related to that. They create an HR diagram with their area of the sky, which I won't get into the details of what that helps them do right now. Pre and post stellar objects, they have to categorize them. They have to find out information about where they are in the sky, magnitude, distance from us, and then identify them as either a pre or post stellar object. Then they have to go out and they have to use Starry Night as well as other programs like and websites like Astrobin, Astronomy Picture of the Day, find the real examples of these objects and discuss them, and different places in the sky that are related to their topic. So stars, dark nebula, emission nebula, open clusters, all of these things, and I'll show you those in a moment. Then they have to look at the multi-wavelength Milky Way website, which is this link right here. And I can actually share this document with you if you'd like. And they have to find out information about the different types of light in their area of the sky and help us figure out, well, what does that do to help them prove their mystery and find evidence. That evidence is very important of the actual process of stellar formation, stellar evolution, and then finally stellar death. and the different types of light. And finally, another part we didn't quite get to in our process was the variable stars. Variable stars are in some sort of change in their particular time, which shows us the process between a star going from one stage in its life to the next. And then there are different types of these variables, which are found at different places on the HR diagram, which brings us back to the Donna-Young activity. Finally, pre and post stellar objects data table. And I have an example of this that was actually produced by students. So here's their pictures of the sky. Unfortunately, I don't have their hand-drawn thing in here. That would have been nice, but I don't have that. Each student has a different part of this, and notice they're just basically labeling in their part of the sky using Starry Night to turn on and off these different types of objects, and this is helping us to gather our data for later use and analyzing. Sometimes we don't have a lot of data, and that's normal, that's real. And students need to learn how to deal with the lack of data. Here's our different types of light and the different types of objects that you can find as a result of that type of light. Okay, and their research paper, everything in red that was written by me, giving them instructions. And then finally their final product, which you can see here. The students were asked to write the paper, showing with evidence how stellar evolution is occurring in the universe above them. Here's a case where I didn't have enough students, so I let them choose one topic to not cover, and they chose chapter 10. Notice how they have images, they have diagrams, pictures, charts, they have in-text citation, they're proving things with backing up their ideas with research. Each topic here is hit by a different student, and they have a whole chapter in their text to tie it to. And they're sharing it with each other, they're sharing it with other groups, and they're working together like a scientific community would actually work. Okay, and finally, their poster template. As I said, we didn't have any groups take advantage of this, unfortunately, just due to lack of time at the end of the semester. I create this poster, we print them out on 36 by 24-inch paper, and they produce a scientific argument where they are actually going to apply the research that they did to convince others that stellar evolution is occurring in the universe around them, and that it is an important topic that we all need to consider. Thank you very much for watching. I hope you enjoyed my video, and I appreciate the time that you all put in to watch. Have a good day.